More and more people getting involved in the work, especially Souter Miller staff, which is very, very cool. So very nutshell-y, WEFTA is all about connections. So that's kind of been our catchword here the last couple of years. We're all about connecting. And if you think of WEFTA as like the hub of a three-spoked wheel, that's the way I think of it, where one of the spokes leads to the communities that we serve, communities that are in need of safe drinking water sources and sanitation, proper sanitation facilities. We're focused on Latin America, so from Mexico to Central America into South America, and we connect those communities in need of those facilities, but that lack the financial resources to fix the problem, fix the problem for themselves, and in some cases the technical expertise or know-how to design and build the needed infrastructure. Connect them with one of the other spokes, the donors. The donors that are folks that have resources, financial resources, have big hearts. They want to do something positive with these maybe excess funds that they have available and want to make a good impact on the world. And the third spoke then leads to the engineers, those with technical expertise, engineers, hydrogeologists, scientists, other professionals that bring the know-how to the communities. So those are the three key elements that we as WEFT are trying to connect. And that third one, that's what's led up to today's presentation that Emily's about to give. She's our latest volunteer to make a trip to one of our projects, in this case, Samaipata, Bolivia. And I know I'm anxious to hear all about it. But one thing I want to say, and we try to do this every chance we get, is to make it clear to everybody within this company. We have so many good people here and really sharp folks. If you want to get involved in the work of WEFTA, please let us know. You can contact me, contact Pete, contact your supervisor, business line manager, whatever the case is. They'll get it forwarded, that message forwarded to the right people. And we'll make sure your name gets put in that pool of resources that we can tap into as the need arises. So without any further ado, let's jump into it. Take it away, Emily.
Hi, everybody. I'm Emily Sotelo. I'm from the Albuquerque office, if you don't know me from the other offices. And thank you for coming and listening to my talk about my recent WEFTA trip to Bolivia, where I performed a water system assessment for the community of Samaipata. So I went down with WEFTA, and as Lou was talking about, WEFTA is a nonprofit organization that seeks to provide clean water expertise to Latin America. And here's a map of some of our projects. You can see that they start in Mexico, and there's a lot in Central America, in Honduras and El Salvador, and going down in Panama. Was one in Colombia, and then we have a bunch in Peru and in Bolivia. And most of our projects in Bolivia have been in the Altiplano, but my project was what is known as the Andes Elbow, and it's where the Andes meets the Amazon. I was working in the community of Samaipata, which has a population about 4,400 people, but there's up to as many as 55,000 tourists coming through Samaipata every year for the various attractions. And the biggest one that attracts a lot of tourists to Samaipata is El Fuerte de Samaipata, which is a pre-Columbian UNESCO site, and it's the largest rock carving in the world. So Lom preceded me in my WEFTA work. So Lom went down in July of earlier this year, and he went down to provide preliminary information about the system and kind of to start our partnership with this community. And he went down and he assessed different parts of the water system, including the water intakes, and most of them are surface water intakes, and basically just small dams that collect surface water. and also wells supply the system. And there's even a new water treatment plant in Samaipata. And then the tanks in the system as well. And so when Lom went down, he worked with the local water cooperative. And Lom worked with them to provide a general assessment of the existing system and also the goals and the needs that were required by WEFTA in a more in-depth investigation visit. And he found and took GPS points of the different sources, and the water cooperative that provides water to Samaipata has about 1,600 connections. The cooperative is responsible for the water and wastewater needs of the community, and there's about 1,600 water connections, but their system is currently unpotable. There's wells and surface water intakes, but water quality tests at these sources and other sources in the system show everything from high fecal coliform to high pH. And the cooperative's #1 goal is to make their system potable. So the water cooperative provided us with a CAD file of the pipelines, and this was not georeferenced to any known coordinate system, and it was in an unusual scale. So we had to use ArcGIS and Google Earth to manually draw in the pipe systems to where they would be in real-world coordinates. But this digital data provided a foundation for our work and our future visit. And that future visit was mine in November. I went down to Samaipata, and my main objective was to map the water system, and particularly the isolation valve. And then this map, I would bring back the data, and then we'd put it in ArcGIS and use that map for design and planning purposes. And my other objective was to train one of the engineers from Samaipata, which is a Bolivian nonprofit organization that WEFTA has worked with a lot in the past. And so one of their engineers was going to come down, and I was going to train him in this asset mapping that I was doing. And while we did that, we used two primary techniques. And so we used two devices, and each had unique strengths and weaknesses. The first one was my smartphone, and I had downloaded a ArcGIS app onto my phone, and this provided an easy-to-use interface, but it wasn't so good in the horizontal accuracy. So it provided a user face that was pretty easy to use. I could take pictures, and the pictures were automatically linked to the points and the locations where it took them at. And it also provides easy post-processing of the data. All of the data is directly uploaded to a GIS database on the cloud. The Trimble GPS is a high-accuracy GPS that is a common and traditional data collection tool. And so we use both of these in conjunction with one another. And we kind of wanted to explore the pros and cons to using the smartphone app and how it compared to the Trimble, just for future asset mapping projects for both WEFTA and SMA. And you can see in this map the purple and the orange dots. The purple ones, I believe, are the Trimble GPS, and the orange ones are the phone. So you can see on average there's about 5 to 6 meters of difference in their position. And this is a map of the accuracy of the points. And you can see about 15% of the points had sub-meter accuracy using the smartphone app. And in average, there was about 13 to 14 feet difference between the smartphone app and the Trimble.
Can I ask a quick question?
Yeah.
How did you determine the accuracy? I know that post-processing the Trimble data, it'll give you sort of a range of accuracy. But here's how were you able to determine the accuracy of the cell phone?
So the question was, for the other offices, was how we determined the accuracy of the cell phone points. So the answer to that is we brought the Trimble data as well as the phone data into ArcGIS, and then we just measured it off of there, what the difference between the two of them were.
so much accuracy as closeness, like proximity.
Proximity between the phone and the Trimble.
The assumption is the Trimble has a higher degree of accuracy. This is maybe more talking about precision.
Yeah, so this map is talking about the precision between the phone app and the Trimble. So while I was there, we were able to complete mapping of the critical portion of the system, which is the central portion. And you can see on there the points of different isolation valves that I collected, as well as other points in the system like junctions and T's, and the tanks as well. And I also was able to train Jaime from Sumahaima on data collection so that he can now go back and GPS different projects that they have, both in the Sumahaima projects and the WEFTA projects that we've done in Bolivia. And I also trained the new engineer at the cooperative of Samaipata that we were working with. And so she's actually going to be the one to finish up the rest of the mapping with her phone using the GIS app. So mapping outcomes, the main outcome that came from the mapping was we were able to delineate theoretical service zones, and that means which part of the system were served by which sources. And it also kind of led us into an unexpected in-depth analysis of the system. Just as we were out mapping, it became real apparent real quick that the system was pretty complicated, and we really needed to figure out how it works and how it operates in order to provide recommendations for improvement. And so I ended up writing an engineering report, a PER, for the system and for improvements. And so as far as operation goes, what we found while we were there is the northeast part of the system, shown here in orange, is served primarily by one source, which is the Tambillo source. And that is a surface water intake. And that flows into the Tambillo tank, the storage tank in between. And that serves the northeast part of the system primarily. And there's an isolation valve that separates this part of the system from the rest of the system so that you can isolate the water into just this part of the system. But unfortunately, none of this water is treated. It doesn't go through the water treatment plant, and there's no disinfection or anything at the moment, so all of it is unpotable. The next thing we learned is on the opposite side of the system are two wells. The Sauce well has a transmission line that sends its water to merge with the other well, and this merged well water pumps into the Concho 8 tank. And both of these wells also have a secondary transmission line, and so each well pumps directly up to higher elevation homes, straight from the well to the homes, and that's done overnight. And again, water in this part of the system is not potable. And then the other thing that we learned was more about the new water treatment plant. So Samaipata actually had a water treatment plant built earlier this year. It started operation around June or July of this year. And so a Bolivian-Spanish nonprofit group was the ones who designed and put this in. And it's complete with coagulation and sedimentation, flocculation, filtration. It even has a GAC filter and disinfection. But only two of the sources are treated at the water treatment plant. And so it's treated by the El Fuerte surface water intakes, which there's actually three of them down on the lower right-hand corner. And those intakes are taken to the water treatment plant through an 8-inch line. And then the other source for the water treatment plant, which is really used as a secondary source during the dry season, is a well by the highway. And this well has a dedicated transmission line into the water treatment plant. And the treated water goes from the treatment plant to Concho 8 tank, which is where the well water also goes to. And there's also some parts of the system that the water goes into as it's on its way to the storage tank. So, and then the last source that there is the Cheerios surface intakes, and there's 6 of them up north, and these are the ones that have very high fecal coliform in some of them. One of them has a very high total coliform, and the interesting part about this transmission line is that there is no storage tank on it, so the water goes directly from the source to the system. And the water from this source comes into the system from the north and mixes with the water coming out of the Concho 8 tank, which is the treated water from the treatment plant as well as the well water. And all of this merges together in the system, and there's no existing valve configuration that we can use to easily isolate the clean water from the dirty water, because it all just merges. And even though we were able to delineate theoretical surface zones, the reality is the water flows where it needs to, so all of it mixes together in the pipes. And so there's no easy way to currently segregate only part of the system to be served by the treated water. And in addition, we found several system complexities, things that just made the system more complex than it would seem to treat it. And so the first one is the one that I mentioned, the Cheerios sources have no tank in between the source and the system. And best practice is that you insert chlorine immediately upstream of a storage tank so that it has enough contact time with the water in the storage tank to provide for enough disinfection before it goes into the water distribution system. So the Cheerios sources go straight into the system with no tank. So there's no easy way to insert chlorine. And then the wells, as I mentioned, both have individual lines that come directly out of the well and go to higher elevation homes. And there's no centralized storage tank for that water to go into. They just head directly to the homes. And so again, that provides issues with having enough contact time for the chlorine. Back up. And then 2 other complexities is the highway well that feeds into the water treatment plant has a very high pH. It's like 8.6, I believe, and that makes the water coming into the water treatment plant about an 8.4. And then chlorine drops off in efficiency very quickly once you get past about 7.5 or 8 in pH. And so the high pH in the water treatment plant, it's reported that the treatment plant, even though it has chlorine, that it's not being very efficient, and that might be due to the pH. And the operators are saying that they're not getting enough residual chlorine coming out of the water treatment plant that would be high enough to meet the standards and regulations at the tap and at the point of use. So the high pH in the water treatment plant may be affecting some of the chlorine that is being used there and making the water treatment plant ineffective in disinfection. And then the last complexity is the transmission line coming from the El Fuerte surface water sources. There are individual taps and user connections along that line. And again, there's no upstream storage tank, so adding chlorine and having enough contact time is, again, an issue for those homes directly tapped onto that transmission line. And so we were able to take all of these different complexities and facets of the water treatment, of the water system, into account, and we came up with a 3-phase approach to get the water system potable. So the first phase will include a chlorinator at the Tambio tank. And so once we add a chlorinator there, then that part of the system, so long as that middle valve is kept shut, for now at least, that part of the system can be pretty easily made potable, at least for the homes that are directly connected onto that part of the system. And phase 2 will include a new tank for the Cheerios sources. And it will also include chlorination at the Chorrillos tank, as well as at the point of where those two wells merge. So there'll be a chlorinator there as well. And for the homes coming off of those wells, for the homes that are served directly by that secondary transmission line coming out of the wells, we're going to check to make sure if the homes have private tanks. And if they do, then we are hoping that that will provide us with enough chlorine contact time. But this will take further testing at the taps once we chlorinate it to make sure that those little tanks at each person's house is having enough time for the chlorine to do its disinfection work. And then as well on phase 2 is working on the water treatment plant and trying to make sure that the chlorine is being effective. And so that starts with water quality testing coming out of the treatment plant to make sure that these claims are substantiated and that the chlorine is not efficient. And if that's true, then we're going to try to drop the pH in the water. We are going to try to do this first by using a different coagulant. And we're going to see if ferric chloride would be compatible with the media in their filters and if it's even available and affordable for them. And then phase 3 of our recommendations include reconnecting as many of those homes that are tapped on to the El Fuerte line to try to reconnect as many of those as possible to treated, the treated system. And
so when you're saying potable, is that for the Bolivian water standard?
Yeah. So the question is, what is the standard of potable water in Bolivia? So the Bolivian standards, they have the Bolivian water quality standards, and they're basically the same as the United States. So the residual chlorine and the fecal coliforms, all of those are the same as they are in the States. So I put all of our recommendations for the water cooperative in a PER, and which is under review. And we will give this to the water cooperative, and then as funding becomes available, they will go ahead and manage this phased approach that we're recommending to improving the Samaipata water system. And this is a picture of the team that I was working with while I was in Samaipata. Starting from the right is Melissa, and she's one of the directors of the water cooperative in Samaipata. And she's the one who made contact with WEFTA and invited us out and coordinated our trips. And then next is the operator. He's the main operator of the water system. And he's the one who really knows where everything was. So we were going around a lot with Don Jesus. And he was showing us where all of the valves are and the other parts of the system so that we could GPS them. And then Jaime is in the middle in the red cap. He's the engineer from Sumahaima. And then in the green is the new engineer for the cooperative. And then myself and Jason Obergfeld. And so Jason lives in Cochabamba, Bolivia, but he has also worked with WEFTA in the past, and he came down to translate for me and to provide some engineering support as well. And I also had a great team back here at SMA in the Albuquerque and Santa Fe offices who gave a lot of support and just enabled me to go down. So with that, I will take any questions that you have. Steve?
So what are they using as a coagulant?
They're using alum.
Are they measuring the water quality of the effluent rate at the plant? Do they know that the plant is operating correctly?
So the question is, are they water quality testing at the effluent of the water treatment plant or somewhere else? And the answer to that is, I'm not sure where they're testing right now. So I want them to do quality testing coming out of the storage tank up there at the water treatment plant. But I'm not sure at what point in the treatment process they are currently testing.
Yes. So they're testing right at the injection just to figure out what the alum is. Yeah. They're testing right outside the tank at the feeding system regarding those sedimentation blocks and flows.
Yep. So and so they're getting good treatment, but just not disinfection?
So the pH, as Emily said, is really high, right? Around 8.4. Yeah. Right. You have a hard time breaking down your chlorine before you pass above 8. Right. So the concept is by using a ferric chloride, switching from a ferric chloride, coagulant, which is acidic, you drop that pH down.
Yeah, sorry, no, I understand. I was just looking for clarification that they're getting good removal of bacteria and all of that. That's my question. So they're getting good removal, but they're not getting good chlorine.
They're getting good TSS, acidity removal, but there is nothing of disinfection. They have spotted their process train for disinfection, but it is not equipped for being business.
So for the other offices, Steve and Lom were just talking about the water treatment plant and where the quality testing is being taken. And Lom was saying it's being taken in the influent and the effluent of the treatment plant, so coming in and coming out. And he was just telling Steve that they're currently using alum for the coagulant. Judy? So the question is, where are they currently getting their drinking water? And the answer is, for the people who can afford it, they buy bottled water in big jugs. And for the people who can't afford it, they are drinking this water coming out of their tap.
Did you taste it?
No. I didn't want to say.
Just curious.
It is technically, well, boiling it will get out the microbacteria, but they said that when they boil it, it still tastes bad, and it still has some sand and turbidity in it. Corey?
Why doesn't the other surface water sources need water treatment?
Wait, can you go back to that one slide that shows the? Go back up to the one showing the watershed. So the question was, why don't the other surface water intakes need treatment plants? And the answer to that is this NGO that is working with Samaipata, and they put in the one water treatment plant. They have plans, or they say that they have plans to put in water treatment plants at each of the other sources, which seems a little overkill as far as just operation and maintenance goes of 3 water treatment plants. And the other consideration is the other 2 water intakes, surface water intakes, aren't as high in turbidity. It's mainly the bacteria in them. And if you look on this, the blue shaded area is the approximated watershed. And so the watershed for the El Fuerte lines is down there at the bottom. And so that's the one that's being fed into the water treatment plant. So overall, that one has more of the turbidity coming into it, which is the need for the coagulation and filtration and that stuff. And the other 2 don't have as high turbidity. Any other questions?
The overall concept of doing that asset inventory was to figure out if we could make certain sections portable. And on top of that was to figure out if we could bring water from those other sources to the treatment plant. As we find out now, that clearly isn't possible. And so, but I was right. The turbidity problems are the ones being serviced by the treatment plant. And that's a solid disinfection of other sources. So that kind of double action would kind of make a significant portion of the system.
So for the other offices, Lom was just saying that our original goal in the asset mapping was to see if we could make certain sections of the system potable. And it turned out that we couldn't. And the other thing we were looking at is if we could bring the other sources into the water treatment plant. But as we were out there GPSing and looking at elevations, it showed that the other sources are at a higher elevation than the treatment plant. And so if we were to pipe that water into the treatment plant, some of those higher elevation homes probably wouldn't be served.
I'm just curious, was there any look at modifying the source, like where they're capturing and how they're capturing that surface water to reduce turbidity and maybe improve water quality by just modifying the source?
So the question is, did we look at the sources to see if we could improve them at all to make the turbidity better? And the answer to that is yes and no. We did not look at moving them at all, but in our report we are recommending best practices for keeping them uncontaminated and for protecting the intakes as much as possible. Because right now, the intakes, if they have anything over them, it's just a tarp or a piece of cloth that tries to keep out the big stuff. But a lot of that sand and turbidity comes right in. Do any of the other offices have questions?
Yeah, Emily, that's a really good presentation. So thanks for putting this together. How do they get the funding? So they have then their own sources of funding separate for construction, and they had requested assistance in analyzing their system. Mm-hmm. Is that how it worked?
Yeah, so the cooperative will probably receive funding from the government, either the municipality of Samaipata or the greater statewide level government or the national government.
Emily, can I hit off that also? So during our first visit, we met with some potential funders that are from, I want to say, the Netherlands, and they take good projects for all sorts of different things, and they fund them. They get their money sometimes from donors, but they also treat it like an investment where there is a rate on the return on their investment. So it's kind of like a loan, but not fully. So imagine a private enterprise which goes out and looks for grants from all sorts of different countries. And so that's one source that we were considering as well. And I can't remember the name of the company. It's some weird Dutch name that I can't remember right off my hand.
Is that one we can dig up and contact for WEFTA stuff too?
Yes, I can give you the contact on that.
Give it to Carla over there.
So I'm curious, you said the organization that put this excuse me, may have plans to do additional treatment plants. What communication and coordination have you had with that group, if any?
With the group that put in the original treatment plant?
Yeah, and you said they may have plans
Yeah.
to do additional treatment plants. I'm just curious what, if any, support or coordination is happening with that group.
So the cooperative is supposed to contact that group that put in the original water treatment plant, and first of all, just find out if they are still the owners of it, because I don't believe it's been transferred over to the municipality yet. And so I have asked the cooperative to contact the group that put in the water treatment plant and see if they're still responsible, and if so, if they could work on the disinfection efficiency, but also to see if this group actually does have plans for treatment plants, or if that's just what the operators have heard or are saying.
Why are there so many sources of water for this community?
So the question is, why are there so many sources of water? And the answer to that is that the surface water intakes decrease during the dry season, which makes sense when it rains less. And the wells are used as backup, so the wells have been drilled as needed. And then it's also largely in part due to homes that are on the outer reaches. And so sources are kind of being found that are high enough in elevation to serve the higher elevation homes.
And on top of that, each clean-ish source, and by clean I mean by Bolivian clean, only produces a small amount of water. With the transient populations, you're looking at an average population size of about 10,000 people. And so you need a lot of those little tiny springs to feed that kind of population.
Okay. Well, if
Do,
anyone
do
has
they have a wastewater? Do they have wastewater collection in there too? Does that feed into that river that runs through there? El Fuerte? Is that what that is? A Rio?
They have a couple of wastewater lagoons that aren't much different than
Okay.
what we have. However, their discharge is untreated and just discharges right into the river, which goes to people downstream. And so in the planning report, we talk about this real briefly. It is a priority for them, but a very low priority compared to everything else. And so eventually they would like to do something about the wastewater, be good stewards of their land.
Because, yeah, in some of the areas, they try to do something at least pretty simple, fully acknowledging what you just said, but they start off with just trash rack type stuff to get the trash out. Generally, if there's a big drainage and it collects from the houses or down the streets or in canals along the houses, then they'll run it through a big trash rack or something like that, and maybe a settling tank pond thing. So anyway, the idea would be to do some simple stuff, primary treatment.
Yeah.
So anyway, go ahead.
Yeah, there's probably going to have to be some stuff done on the primary as well as some level of disinfection on the discharge.
Yeah.
So I am curious, some of the water sources, I can't remember the name, but the ones on the southeast over there on the blue line, they appear to be really close to the boundary of that watershed, although I'm not sure what sort of scale that is. Are they able to undertake any efforts to protect that the watershed above that source, or is that developed and there's really no opportunity to provide protection upstream of where they're grabbing that water?
So for source water protection and watershed management, they actually have a whole other NGO looking at that problem out of Santa Cruz. And yeah, that one's being done by them. I can't remember the name of it right now. I have to check my notes, but that is a problem that was acknowledged and is being taken care of by the others.
All right. Well, if anyone has any other questions or is interested at all about reading the report or anything, let me know. And otherwise, thank you for your time. And I would just like to send a special shout out to our WEFTA people, for Lou and Karen and Carla, who helped coordinate the trip, and also for Scott here in the Albuquerque office, who's our resident GIS expert, and gave a lot of help and a lot of input putting together the presentation and helping with maps and stuff. So thank you, and we'll talk to you guys later.
Thanks a lot, Anne Marie.